Today I just want to give a quick tutorial on how to use function pointers to make functions more generic and more useful. And I'm going to use the previous tutorial on counting history and counting current orders as the example for this. This is the history count for script, which I used in the last video to show how to loop through history and current trades to gather information. And in here I have used a structure to gather all of the information I wanted during that loop. Also in the history count 3, I showed how to use the typedef to create function pointers. I've included a link to that earlier video in the description below, and there should also be a link on screen if you want to see that. Today I'm only going to be showing the relevant points for the function pointers. When I made the earlier video, which was about accumulating trades based on setting a start and finish time, I explained that the function that I wrote would only test the order open time, and if you wanted to test something else you would create additional functions. This is one of the problems that I will overcome today by using function pointers. I've already created this script called history count 5. I've just added a small comment at the beginning to indicate what we're doing, but otherwise so far this is a complete copy of history count 4. So to go over the relevant parts here, I explained earlier that I can use a structure to accumulate data from the trades as I go. I also explained that if that structure includes an array, like this order ticket list array, then it's harder to initialize the structure. Typically you can initialize a structure by assigning just a 0 to the first element, and all the remaining elements will be assigned a 0 as well. But once it includes an array or any other type of object, then you can't do that. But I also then explained that if I create this SOrderTotal simple, which has only basic data, and then I can create my SOrderTotal structure, which is based on SOrderTotal simple with this colon notation, then I can add the array to the SOrderTotal. And then if I go to where I'm doing the initialization on that, here in this initialization section, I'm creating a new variable called temp of type SOrderTotal simple. I am able to assign a 0 to that, which will zero out all of the values in the temp structure. And then I can simply assign that temp structure to the total structure, which is defined in the inputs to this function as SOrderTotal. So I can assign the simple structure to the complex structure, and that only leaves the array to be initialized, which I was taking care of later. But I still have the problem that I'm only testing on one value. This loop has a condition. I'm specifying the start and the end time. And now let's look at using function pointers to make that better. So here's the first step. I'm using the typedef keyword to define a function pointer. In this case, I'm defining a pointer called tOrderValue, using the asterisk notation to say that this is a pointer. So I'm creating a type. The type is called tOrderValue. It's a pointer to a function that returns a double and takes no arguments. And I'm going to use this so that I can generically call the functions to get order values. And now I've created 4 functions for this example: open time, close time, lots, and profit. All they're doing is returning these internal functions for order open time, order close time, but I can't use these internal functions directly as function pointers. It's just not allowed. So instead I'm creating my own function names. I'm making them all doubles, so even though I'm returning an order open time, I'm casting that to a double by preceding it with this double statement, because the typedef says that this tOrderValue pointer is to a function that returns a double. So now I can use any of these 4 functions, and they are all of type tOrderValue. And I'm going to use these to be able to pass that function name in as part of the comparison that I perform. I'm also going to create an alternate method for having a flexible comparison, and you'll see when I get to the example of using these how they're different. So in this case, instead of defining a function that returns a double, and then inside my loop through orders where I'll compare the value of that to my limits, I'm creating a Boolean function. So again, typedef a pointer, creating a function type of TOrderSelect. It returns a Boolean value and takes 2 arguments of type double. So instead of, as I said, in the loop going through and getting these values, the flexible values, and comparing them inside the loop, an alternate method will be to call a function of type TOrderSelect, which will simply return a Boolean telling me whether I can include that order or not. And you'll see as we get to the loop how one or the other might be more applicable to you. And then another case of using a type definition will be to make the accumulation of data flexible. So I'm also going to declare a function pointer, which I'll call TOrderTotal. It returns a void, but it accepts a reference to the SOrderTotal structure using the ampersand here. Now first I'm going to replace the SomeOrders function with a new function that takes the flexible function to give me the value that I'm going to be using in the comparison. I've called this function SomeOrders1 because I'm going to be creating a second function called SomeOrders2 where I use the alternate comparison method. So here I've already added in a comparison, or passed in value for string and magic number because I'm going to use those in the comparison, and the order type. These limit low and limit high would previously have been the start time and the end time, but now because I want to be flexible in the values that I'm comparing, I'm declaring those doubles. Dates and times are just numbers, so I can pass those as doubles as well. And here is the TOrderValue function, which I'm just calling FValue, that will return a value from the current order, which I can then use in the comparison later. The mode will be used to select whether I'm scanning through history or current orders. And then here is the function TOrderTotal type, which I'm calling FOrderTotal, which I'll use to accumulate the values. And then the structure of type SOrderTotal, which will be passed into that FOrderTotal function. And then finally, this Boolean reset equals true is used in this condition if I want to know whether to reset the values in that total. So now I can get rid of the old definition here. So this if reset doesn't change. I'm still selecting my count based on the mode that was passed in here. I'm going to declare one additional variable to use in the loop. And that's because I'll be referring to the value that comes back from this FValue function more than once, and I don't want to call the function repeatedly to get the value. Previously, my condition here just filtered out type balance orders. I'm also now adding in the symbol and the magic number and the order type, so let me put the conditions for those in. So what I'm saying here, if the symbol is equal to an empty string or it matches the order symbol. So you can pass an empty string and get all orders. And similarly with the magic number, if it's less than 0 or if it matches the order's magic number. So you can pass in a -1 to get all orders, or pass in a specific magic number just to get orders for that expert. And again with the order type, if it's less than 0, I'll take all orders. Otherwise, I'm only selecting order types that match. But in all cases here, I'm filtering out type balance. Now, here is where I'm using the function pointer passed in, the FValue function, which is of type TOrderValue, and this returns a double value. So I'm simply saying order value, this variable which I declared earlier, gets the result from the FValue function. And depending which FValue function I've passed into this, it will get the open time, the close time, lots, anything else that I want to declare. And then in this condition statement, I'm simply saying if the order value is greater than or equal to the low limit, which was one of the arguments passed in, and it's less than or equal to the high limit, which again is an argument passed in. And this is the old condition, so I just remove that. So now I can pass a different function along with the delimit values, so I could use this to find orders that are in profit, orders that have made a loss, orders between certain open times or between closed times, anything that I can return a double value from the order. And then I've also passed in here a pointer to an order totaling function. So rather than go through all of this accumulation here, I can remove all of this and simply make a call to the FOrderTotal function, passing that total structure, which was passed in by reference here. So I'll be accumulating values into that. And in this way, I can either change the way that I'm accumulating values, or I can decide to accumulate some or more values by simply passing in a different function here. Now I'll just create one function that's an example of the FOrderTotal function. This includes all of the same lines that were in the history count for accumulating order totals. I haven't made any changes. I've also just called it FOrderTotal, but using a capital F, where the variable name here is a lowercase f. It's a minor distinction. It's probably not best practice, but it will work for this tutorial. So I've created a function called FOrderTotal. I'm just accumulating everything. But you can see that if I simply change this, I can conditionally accumulate profit or lots, or I can change the amounts that I'm adding there, and I can add new variables, remove them. So this is a flexible way of doing the accumulation. And it all is done through this call, which will call this FOrderTotal and pass that total value for accumulation. So now let's use this SomeOrders1 function just to show how it works. I'll just remove all of these lines. So I'm calling SomeOrders1. I'm actually passing in the chart symbol rather than an empty string, but I'm then saying -1 for magic number and -1 for order type. So I'll accumulate all trades for the symbol and all order types. Passing the input start time and the end time, which we've adjusted here in case end time is 0 to be the current time. And I'm passing the function for close time. So this means I'll be doing a comparison based on the close time. I'm using mode history, so I'm looking through closed trades. And I'm using my FOrderTotal function to accumulate the order total value. And because I'm not passing the last argument in the reset, the default to that is true. So this will also initialize order total to 0 before it begins the loop. And then I've simply got a formatted string to show the results, a list of the tickets, and then I'm making the same call again for the current orders, in this case passing mode trades, so I'll get current orders, still using current symbol, looking at all magic numbers and all order types between the start time and the end time, looking at close time, and because these are current orders, I'll get no results for that, because they won't have a close time. And I'm accumulating into the same order total, and I've passed in false here, so this doesn't reset the order total, so it will accumulate onto the values that we had previously. And then I'm again showing the results for that using the for all and the list of all the tickets I found. So that's using SomeOrders number 1, and that is the option where I'm using this typedef, which returns a double value, and then I'm performing the comparison inside the SomeOrders function. Now let's look at an option where I pass this function name or this function pointer, and then that simply returns a Boolean value. So here I have the second example. I've called this imaginatively SomeOrders2. I'm still receiving a symbol, magic number, and an order type, and I'm testing those in the same way. I'm still getting a low limit and a high limit, but in this case I'm passing in a TOrderSelect pointer to my FSelect function. Again, there's a mode being history or current trades, the OrderTotal function, which I'm using the same function for because I only have one, and passing in my OrderTotal structure and the Boolean reset true. So reset is the same, the count is the same. I don't need a variable here to hold the value of the trade because I'm not returning a value from the trade. Here in my conditions, again the order select, I'm testing symbol, magic number and order type, just the same as in example number 1. But then I'm simply saying if FSelect, which is my flexible selection function, and passing in the low and the high limits. So this function will test something from the order, and that something is decided inside the function that I'm passing in here, and it will compare that sum value from the order against the low limit and the high limit. And then here I'm just using the FOrderTotal to accumulate the totals again. So let's create two FSelect functions to see how they would work. Now I have two order select functions, FOrderSelect by open time and FOrderSelect by close time. By open time is fairly simple. If the order open time is greater than or equal to the low limit and less than or equal to the high limit, then it's going to return a true. Just to do something a little differently, in the select by close time, I've also added order profit is greater than 0. This is just to show that you can modify these functions and they don't have to be simple comparisons. You can add anything you like into this function. I could have probably more appropriately called this order select by close time in profit if I wanted to. But both of these functions, they return a Boolean and they take two arguments of type double. And that's why they can be used as the same function pointer. So simply by passing in a pointer to each of these functions, I can perform different tests inside that loop. And now to use this SomeOrders2, I would call the SomeOrders2 function, again passing the symbol, magic number and order type, start time and end time, because they're the only two inputs that I have, but you could easily modify these inputs to be minimum profit, maximum profit, anything you like. And then I'm passing in the selection function, so in this case select by close time, which remember I set to only accumulate totals that have a profit greater than 0, and still passing mode history and using the FOrderTotal function to accumulate into my OrderTotal structure. And then here, where I'm accumulating from current orders, I can call SomeOrders2, passing the symbol, magic number, order type, start time, end time. And here, because these are open orders, I'm going to select by open time. So I'm passing the other function, which doesn't have the condition to accumulate only profitable trades, but this is just an example. And then again, the FOrderTotal function, accumulating into the OrderTotal variable. Because I can only really run one of these at a time, I'm just going to start by commenting out SomeOrders2, I compile that, and then I'll go to the terminal where I'll create some trades and then show the example. Now in the terminal I opened 4 trades. I opened a buy and a sell on the euro and a buy and sell on the Aussie. I have closed one of each of those. So here's the buy on the Australian that I closed and the sell on the euro that I've closed. And I have the AUD USD chart open. So remember, we have a filter inside the script to only look at this symbol, or the symbol on the current chart. So if I run history count 5, I'll leave the start and end dates at 0, which means I'll accumulate everything. Now it's telling me for history count 1, although I have 2 trades here in history, only one of them is for Australian dollar. So I'm getting count 1 profit minus 0.19, which is correct. And it's showing the time that that trade was opened. So first time and last time are the same because I only have one trade, and the low price and the high price at 0.74. And then ticket number is 7699, which is correct. Then I'm making the second call to accumulate the current trades as well. And now I have 2 trades because I still have one Australian dollar trade open. Total profits minus 0.41, total lots 0.02, and so on. And now I have the 2 ticket numbers, which includes 7708, which is the open trade. So now I'll go back and recompile using option 2. So here I'm just going to comment out SomeOrders1 and remove the comments from SomeOrders2. back to the chart, and I will again run history count 5. Nothing has changed. Still running for all dates. But now you can see for history count equals 0. Remember, I had a profit of minus 0.19, and my history count, I was passing in the function that tested close dates but also checked for profit greater than 0. So I'm showing 0 now in the history count with no tickets. And then when I include the count on current trades, because I was calling the open date for this and I was not testing for profit, then I now have a count of 1. So just a quick example of the flexibility you can get by using typedefs to create function pointers. And that also removes one of the restrictions in the earlier example of history count 4, where it would only test a single value. So I hope you found this useful. If you have, then please click the like, and if you'd like to see more videos like this, remember to click subscribe, and if you click the bell icon, then you'll receive a notification when we post new videos. So until next time, thank you for watching.